Hi everyone, Looking here from OhmLab. I'm here to give you a quick update on our progress with the Arduino core for the Neuro N6, show you an example sketch for running inference, as well as viewing some overlays in Neuro Studio. So let's jump over to Arduino quickly. So as you can see here, we've got a very simple sketch, including our core library for the Neuro N6. So at the moment, this is just starting the camera in VGA resolution in the YUV42 format. That's the format used by the JPEG encoder on board the Neuro N6. So if we go to Neuro Studio here, so this is a feed from the Neuro N6, about 50 FPS at VGA resolution. There's no inference running on board at the moment, so there's no overlay options. So let's just talk a little bit about how Neuro N6 sends frames to Neuro Studio. So it's using a custom vendor communication protocol over USB. So the reason we're using that is because it's ultra lightweight and it's very easy to port cross-platform if we use our own custom app like Neuro Studio. So if we go back to the Arduino core here, you see there's nothing in the loop. And that's because the Arduino core handles sending frames to Neuro Studio in the background. So whatever you put in the loop here, Neuro N6 will always be sending frames if you have started the camera. So that makes it very easy for the user to implement their own code without having to worry about viewing frames in Neuro Studio. So we will be exposing more options to do with camera, ISP, and resolution, format, etc. as we develop our Arduino core. For the moment, the core functionality is there. Okay, so let's take a look at an example sketch of the Neuro N6 running inference in Arduino. So let's just hit upload here. So this is an instance segmentation model with 80 classes. You can see the classes table defined here, all the different names. And again, down at the bottom here, we've got our setup and our loop functions. So once this is done uploading, let's take a look in Neuro Studio and see what that looks like, and then come back to look at the code. So there you go, we've got instance segmentation running on the Neuro N6. So this is at about 22, 23 FPS. See that font over there. VGA resolution, and it's running at about 38 milliseconds. So that's about as quick of an FPS as we can get with this model. So yeah, you can also toggle overlays on and off, any combination of overlays. Let's give you an example of it, detecting some more objects. So I've got my mouse, bottle, dining table, you've got a couple of chairs in the background there. Yeah, this is quite a fun model. We've got a few demos of this on our social media. So the demo of us, detecting the animals, the pigs, and the birds, as well as counting cars. That's all running with this model here. So the way Neuro Studio is processing these overlays is it's getting sent metadata between frames from the Neuro N6. So only a few bytes, and it processes them very quickly on the host. So that offloads some of the work from Neuro N6 and allows you to run the neural networks at a slightly faster frame rate. So the reason why this overlay is not quite extending to the edge of the frame is because neural network input is a square, and because this frame is slightly wider than the square, it's just the edges here that get cropped out before they get fed into the neural input. So let's go over the code a little bit. So we've got a couple new libraries here. So we've got the Neuro ART and the post-process library. So the Neuro ART is exposing some easy-to-use functions, allowing you to take advantage of the neural processing unit in Arduino. And we've got a post-process library here. So this will be filled with loads of functions for several different types of neural networks, as well as an easy API for you to craft your own custom post-processing functions. If we go down here, we've got the same camera start function. So we're viewing in VGA resolution. You can obviously change this and that will change what resolution you're viewing in, and this will not affect the input to the neural network. That's handled later. We've got NPU initialization function, so that initializes the NPU caches, the RAM, and also initializes the input and output buffers for the neural network. That's all handled within this one easy function here. Then you've got your inference loop. So first of all, we're starting a snapshot of one frame. So that's in 256 with 256 resolution with an RGB 888 format. So this is a pretty standard format for most neural networks. Then we run inference on that frame, and then we post-process. And this creates the metadata, which is then sent to Neuro Studio via the background process that happens in this loop. So yeah, that's essentially it. Pretty simple loop, and you get to see instant segmentation running in Neuro Studio on the device. So if we go back here, we can obviously change these class names. If I change this to man or something, so let's put my name down, and then we'll upload that again, and you can see that it now names every person as Mukund. So yeah, with this post-process function, this is currently all we have in our post-process library, but this is just to show you the core functionalities and that the Neuro N6 does actually work in Arduino. And of course, we'll be updating all of these libraries with more functionality as time goes on. So there you go. It now has correctly predicted me with a 94% confidence. So yeah, I guess that's everything for this demo. Stay tuned for more demos where we'll be showcasing other models in Arduino as well as some further functionality with Neuro Studio. Thank you.